Assalamualaikum warahmatullahi wabarakatuh. Hi, we meet again. My name is Wulan, and now I'll talking about equilibria in an ideal systems, such as here the concepts of activity, the rational system of activities, colligative properties, and the practical systems. And let's begin from the concept of activities. And for a concept of activity, the chemical potential of a component in a mixture is in the general a function of a temperature, pressure, and the compositions of a mixture. In gas mixture, we write the chemical potential of each component as a sum of the two terms. Mu I equal mu I degrees times T plus RT ln Fi. The first term, mu I degrees, is a function of temperature only, while the fugacity Fi in the second term may depend on the temperature, pressure, and compositions of a mixture. The fugacity is a measure of the chemical potential of the gas I in the mixture. In the method of evaluating the fugacity for a pure gas was described. Now, we will combine our attentions to liquid solutions, although most of what is said can be applied to solid solution as well. For any component I in any liquid mixture, we write mu I equal Gi times Tp plus Rt ln Ai, where G times Tp is a function only of temperature and pressure, while Ai, the activity of I, may be a function of temperature, pressure, and compositions. As a stand, in a particularly informative, however, it does indicate that at a specific temperature and pressure are an increase in the activities of a substance. That means an increase in the chemical potential of a substance, the equivalence of the activity to the chemical potentials through an equation having the forms of is the fundamental properties of the activity. The theory of equilibrium could be developed entirely in terms of the activity of substance instead of in terms of chemical potential. These the equations significant of the function Gi times Tp must be accurately described. Then Ai has a precious meaning. The way to describing Gi times Tp are in common use each leads to a different system of activities. In either system of activities of a component is a still measure of a chemical potential. That was about our concept of activities. And next, we're talking about the rational system of activities. Okay, the next is about the rational system of activities. So for rational systems of activities, we just have now about here these equations. I hope you can see it clearly, so you can read the equations, and you will learn about this equation of the rational systems of activity. So this is the equations. the first, seconds, and next here, and here is the final equations of the rational system activities. So for the final equations here, mu I equal mu I id plus rt ln I y e. That y is a measure of extent of deviation from ideality. So of yi, we have a yi equal 1 as the xi become 1. So the rational activities coefficients are convenient of the systems which the mole fraction of any component may vary from 0 to unity. Mixture of solid such as acetone and chloroform for the example. So here this equation that we know is to help you to find the mixture of the liquids such as here acetone or maybe chloroform for the example. So this equation will help you to know about the mixture of the liquids. So if you already know and learn about the rational systems of activities, we have a curve, we have a figure of activities versus mole fraction and activity coefficients versus mole fraction. So how we get these curves from this equation? Make it know about the activities versus mole fraction and activities coefficient versus mole fractions. So this rational systems of activities and volatile substance is about the activities and mole fractions. So this is the first figure and this is the second. Why this is different? Because this is the activity and this is the activities of coefficients. So in the activity versus mole fractions, just activity, this is the positive deviation and negative deviation. So the curve is ideal in EI and XI, but in the activity of coefficient versus mole fraction, there one here, like we said before, yi equal 1, same as 1, and xi to becomes 1. So for that, we get this activity coefficient versus mole fraction is 1. So the positive deviation and negative deviation is make 1 is the ideal of xi as different from the first one that we get the activity versus mole fractions. So that was the difference curves between the activity versus small fractions and activity coefficients versus small fraction of rational systems of activities and rational activities of volatile substance. So that was about the rational systems of activities. What about next? Next is about colligative properties. And the next that we're talking is about the colligative properties. For the colligative properties, we should know that about vapor pressure, freezing point depressions, boiling point elevation, and the last one is osmotic pressure. So this for matter is talking about colligative properties. So if you want to know about what is colligative properties, here: vapor pressure, freezing, boiling, and osmotic pressure. So for the first one is the vapor pressure. Here the equations is A equal P divide P degrees. So you can see it clear, I hope. And here the the equation and how you can apply that equations. And this is for the freezing point depression. Here are the equations. And boiling point elevation, heat equation, and osmotic pressure. So if you want to know what the value of vapor pressure, freezing point depressions, boiling point elevation, and osmotic pressure, here the equations here to help you to know how you can get the value of vapor pressure, freezing point depression, boiling point elevation, and osmotic pressure with the equations. So this is about colligative properties. So these colligative properties, I think this kind of simple to know for you to learn about it. So I think just that for the colligative properties. You just should know learn about these equations about vapor pressure, freezing point depression, boiling point elevation, and osmotic pressure. If you know about this form matter, so you can get the point of colligative properties. So that's about the colligative properties. And what about next? Next is about here the practical systems. Yeah, last but not least, right, the practical systems. For practical systems, that was the equations of that. That was mu h equal mu h plus RT ln A join. So that's equation for the that was the like that's the general equation of a practical systems. But in the practical system, we also are talking about this three of matter: volatile solid, in volatile solids, colligative properties, and the activity of a solid, and freezing point depressions. So we're talking about these three matter one by one, right? So the first is the volatile solid. For the volatile solid, the equilibrium conditions of distribution of volatile solids joint between solution and vapor is a mu joint G equal mu joint L. So if you want to know about volatile solid, that's like final equations. That was Pg divide Mg in Ng since it's 0 equal K action join. So having obtained the value of K action joint, the value of A joint are computed from the measure P joint. So that was about volatile solid. The next one, after we know about volatile solid, we will talk about the involatile solid. Like if before we talking about volatile solid, here the involatile solid, that such as the colligative properties and the activity of solid. If we talk about this, the colligative properties is the rational activity of a solvent. These properties can also be related to the activity of a solid. Symbol will subscribe refer to the solvent. Symbol with the subscribe to refer to solute, except that the molality of a solute will not bear the subscribe. For simplicity, we assume that only one solute is present. So for the final equations of involatile solute, colligative properties and activity of solute is using the value in Gibbs-Duhem equations. You know, Gibbs-Duhem. That he making the equation. So that's named the Gibbs-Duhem equations. That was D ln E equal minus N2 divide N D ln A2. So from the Gibbs-Duhem equations, where N divide N is molarity and molality, where N is molar mass of the solvent and M is the molality of the solid. So M is a molar and M is a molality. So D ln E equal minus mmD ln E2. So which is the required relations between the activity of solvent and solute? And finally, the last one is the freezing point depression. For the freezing point depressions, it's more that's not easy to know about the freezing depressions, but I think we just should know for the final equations. And the final equation is the integral, and the final, for the final we have an integral for the equations. So if this freezing depression is use the integral for that equation. So we have assumed that each fuse is independent of temperature and that theta is much less than T0. In precision word, more elaborated equation not restricted by these assumptions are used. Any of the colligative properties can be interpreted in terms of activity of solute. Okay, that's all about my explanation. Don't forget to like, comment, and subscribe our YouTube channel. You enjoyed this video, right? So see you next time in next video, and stay healthy. See you. sampai. Wassalamualaikum warahmatullahi wabarakatuh.